Let's start today's topic on graphing parabola. We've discussed most of these already, but let's focus more on how to graph precisely the general parabola function. So here, let's start with this case: y equal to ax minus h squared plus k. This is a format that we've discussed already. And if you remember, we discussed it for f of x equals ax minus h squared plus k. And we said there is a transformation starting from x squared function. If you start from an x squared function, there's a transformation originally x minus h squared from x squared to x minus h squared. You would do a horizontal shift because you're making a change. This was if it was x plus h squared, then you would go opposite direction. Now, since we picked x minus h squared, if h is positive, you go to the right. If h is negative, you go to the left, because there is already a negative sign in between. There is already this negative there. So you have x minus h. So there is a horizontal shift, first step, from x squared. Then what do you do is deal with that coefficient outside. The next step of the transformation was rescaling. If a is negative, there will be a reflection as well, but you can do that just by rescaling. And what does the effect? It affects the y values. The y values get rescaled by a, so you get multiply a by y, all the y values. The x values will stay fixed. And then finally, that constant k at the end is a vertical shift. That would be your third step. By doing that, I'm gonna show you what happens. So here we start with x squared. This is x squared. Let's say we move this k unit, h unit to the left or right. So let's say we moved it h unit to the right. This is h. Okay. Then we rescale it. That means that rescaling was a stretch or shrink. So let me pick a different color. So let's say rescale it. We stretch it along the y direction. Okay. And the final step was to after rescaling, you shift it up or down, k unit up, for example, you'll end up here. This is shifting it up, sorry. Say shifting it up k unit. Everything will move up k unit. So this location, if you look at this location, this is k unit up. That is the vertex of the graph. And we already mentioned that the vertex is a unique point. If you figure out the vertex, then it would be easier to graph it. What is the coordinate of that vertex through this transformation? It turns out to be exactly h and k. H is the x coordinate and k is the y coordinate. So when they say the vertex of a parabola of the form y equals x minus a times x minus h squared plus k, the vertex is exactly at h and k. That's why we have this format. So the graphing for the function would be much easier if you know the vertex point. Here, let's do an example. For example, if given y equals 2x minus 1 squared plus 3. You can already figure out where the vertex is. It's not necessary, but if you do it, it's going to be easier. What is the vertex? This is h, that is k, so it would be at 1 and 3. So if I graph the function, I know at 1, and let's say this is 3, and 1 and 3, that's where the graph is. So the graph has some shape like this. It would be easier if I knew a couple of points on the graph. Normally, we will look at this y-intercept, and if there is an x-intercept, we figure out the x-intercept. If there is no x-intercept, you figure out another point to graph the function. So let's assume at the moment we only know the vertex point. We know the vertex is there. So either the graph looks like this, downward or upward. Which case is it? You look at the coefficient. If a is positive, then rescaling is going to be only stretching along the y direction or shrinking along the y direction. But if a was negative, then you have to reflect. This causes a reflection. In this case, a is a positive number, so this is a positive, so it's going to be upward. This is a negative, it would be downward. In this case, A is positive, so you would have only the positive direction. You do not have the other way. So what do? I pick maybe a couple of more points if I want. So I pick X, Y. I already know the vertex 1 and 3, so maybe I'll pick 0 and 2, for example, for the X coordinate. If you replace 0 into the X, what you get is 0 minus 1 is 1 squared is 1 times 2 plus 3, 5. If you replace 2, you'll get 5 as well. So at 0, I have 0 and 5, as well as at 2, I'll have 2 and 5. This is 2. So now I can graph the parabola, say, here, how the parabola looks like. It's easier if you find out where this vertex point is. Otherwise, if you have these 2 points, you'll be able to estimate exactly where the vertex ends up. If you pick a couple more points, your graph would be more precise. Not necessary, but it's good enough at this point. Here, let's try one more example. And scroll down a bit. You can go through this process by the shift and horizontal and vertical shift, but it's not necessary. Let's say I have minus 2 times x plus 1 plus 2 plus 3. Let's say I want to pick different numbers, so this way it's easier to see the difference. So here plus 3. Okay, let's do this as well. Okay, so where is the vertex? Remember, the vertex is at h and k, but this is not h. This is negative h, because you should have a negative in between, x minus h. In this case, h is negative 1. It's not positive 1, right? The formula that we have, it's y equals a times x minus h plus k. This is exactly k, so k is 3. But h would be the opposite. H should be negative 1. In the last example here, we already have the minus sign. So h was simply 1. And here we do not have that negative, so we add an extra negative and we write this plus 1 as x minus minus 1. That's how we look at it. And we say h must be negative 1. So I have the vertex point. And since a is negative 2, a is negative 2, equals negative 2. Therefore, a is a negative number. A is negative, that means the parabola should be downward. This is the case of a negative. Last example was a positive. A was positive 2 as a coefficient. So now you can draw this. Find the vertex first. Vertex was at negative 1 and 3. Negative 1, 3. That's the vertex. Negative 1, 3. Again, you need a couple of points. X, Y. I'll pick negative 2 and 0, just because I want it to be close to the vertex point. You can pick 3 and 5 if you want, but it's better if you pick close to the vertex point. Your graphing would be more accurate. 0. I picked negative 2. Sorry, not Y, 0. This was... Okay, negative 2 for x, 0 for x. Replace negative 2 for x, what you get is positive 1. If you replace 0, you'll get positive 1 again, sorry. You'll have positive 1, 0, positive 1, 0, negative 2. And what does the graph look like? Looks like this. Later on, we discuss how to find these exact points. If you know these points, these are the x-intercepts. You'd find out where the x-intercepts are. It makes the graphing much more precise. Okay, I think this is clear enough for this type. It's not too difficult. But there are other cases. You have a general form of quadratic, y equals ax squared plus bx plus c. Now graphing this is not going to be through transformation anymore, because you cannot start from x squared and then add an x later, because this is a combination of a quadratic with a linear function. It's not going to be through transformation. What you can do is, in two cases, there are two ways to deal with this. One is rewrite this in the form that we had earlier, ax minus h squared plus k. Try to rewrite it this way because it's quadratic. You should be able to do this. But this is sometimes it's gonna cause, it's gonna be more difficult to do this than writing it through the vertex point by picking a couple of points. So what I'm gonna do is I'm gonna ignore this idea unless the graph is written in that way. And I'm gonna just say the vertex, if you have a quadratic function of the form ax squared plus bx plus c, if you have a parabola, the vertex happens to be at negative b divided by 2a, and the y value comes in by replacing that x into the function, into the equation. Now, I'm going to give you a brief idea of where this vertex point comes in. If you figure out where these 2 points are, if you look at the graph and say, figure out where are these 2 points. These 2 points is where the y value is 0. That means if we replace 0 for y into the equation. So what you have is ax squared plus bx plus c equal to 0. And this is a quadratic equation. Based on the quadratic formula, what is the solution? The solution is negative b plus or minus square root of b squared minus 4ac divided by 2a. What is this? This is the two solutions. You'll get one is, let me erase this, negative. This is one of your solutions. The other one is exactly the same thing, but plus sign between, minus 4ac divided by 2a. These are the two solutions. This is maybe, call it number 1, number 2. This is solution number 1, that is solution number 2. The x coordinates of these two. Where is the vertex point? The vertex point is halfway exactly in between those two. So if I know these 2 points, then I should know exactly where the location of the x coordinate of the vertex is. How do I find the average? You add them, divide by 2. So if you add 1 and 2 together, 1 plus 2, if you add them together, what you get is these two will cancel out because they're opposite of each other. So what you get is minus b divided by 2a plus minus b divided by 2a. By adding those, the radicals will cancel out. And then you divide by 2 since you want to take an average. This is how you find the average, right? You add the 2 numbers and divide by 2. Add 1 and 2 together, divide by 2. And what you get at the end is negative b divided by 2a. Because this would be negative b divided by a divided by 2 again. So this negative b divided by 2a is basically the x coordinate of the vertex. It's exactly this location is negative b divided by 2a. How do you find the y? You replace negative b divided by 2a into the equation and you find the y value. You replace x with negative b divided by 2a everywhere. By doing that, you can find out the y coordinate. That's what I called it f of evaluate the function at that point, at the point negative b divided by 2. It's very important that you know how to find the vertex of a standard form of a parabola, a quadratic equation. Here's an example. And I use that vertex point to my advantage and graph the function. By the way, this a, again, in this case, is the coefficient of x squared, 3. Okay, so the a is coefficient of x squared, 3 in this case, and it's a positive number. So what do I expect from the parabola? It's an upward parabola. It's very important to notice this. In the graphing, you can always figure it out by picking points, but it's important to know that and what do you expect to get at the end. How do I find the vertex? Negative b divided by 2a. That's the x coordinate. And y coordinate, how do I find the y coordinate? I replace x into the function. So let's figure out the vertex first. b is negative 12. So I will divide minus 12. Divided by 2 times a is 3. And I will figure out the y value later. I'm going to just rewrite this a couple of times so you can see what I'm going to do. Negative 12 is positive 12 divided by 6. X coordinate turns out to be 2. If you simplify, this is equal to 2. And I need to figure out what the y value is. How do I find the y value? replace 2 into the function. It's f of 2. But there is no function here, so that's why I do not want to use the f notation. What I'm going to do is I'm going to replace 2 into the function and figure out what the y value is. 3 times 2 squared minus 12 times 2 plus 10. By doing this and calculate all these, 3 times 12, here would be 12 minus 12 plus 2. You'll get plus 8. I hope I didn't make any mistake. Let's try 2 times 2, 4, 4 times 3. This is 12 minus 24 plus 10. 12 and 24. Oh, this 8 is not right. 12 and 10, 22 minus 12, negative 2. Actually, y is negative 2. So I figure out the vertex point. This is the vertex. So when you graph the function, you already know the location of the vertex. 1, 2, 1, 2. 2 and negative 2. This is the vertex point. So what do? I expect the graph to be downward. Somewhere like that. I just need to figure out the one y coordinate. So I'll pick some x and y. A couple of points on the graph. To make the graph more precise. What do I pick? I pick some numbers close. Something like 1 and 3. If I pick x equal to 1, x equal to 3. Replace 1 into the function. What do you get is 3 times 1 minus 12 plus 10. 13 minus 12, you'll get 1. If you replace 3, y value turns out to be 1 as well. Sorry, minus 1. If you replace 1, what do you get is... Oh, I made a mistake, sorry. A was positive. I thought A was negative. This was not correct. Yes, here we go. Now that makes more sense. If you replace 1, you get 1 and 1. Let's assume this is 1. And what does the graph look like? Going through these points. Let me erase this. Sorry. I went too far. 1, 3, you'll get 1 and 1. I wanted to erase this 1 and 3. They're in the way. Okay, so here at 1, we have 1. At 3, we have 1. And graph this parabola through those points. My graphing is not good, but here, if I ask you, what is h and what is k? Can you answer this? Because if you can answer that, you can rewrite the equation. H would be, remember, the vertex point is at h and k, so h is 2. K is h and k. K is negative 2. So if I ask you to rewrite this function in the form of ax minus, if I ask you to write this equation in the form of ax minus h squared plus k, then you already know a is given 3, x minus h is given, we figure out h is 2, k negative 2. So now I have that form of this equation. By the way, if you raise this to the power 2 and distribute, you should get exactly that equation. These two are equal to each other. So if you figure out the vertex point, it wouldn't be difficult to figure out exactly how the graph is going to expand and look like. You can do another example if you want. Y equals, let's say, minus x squared minus 4x plus 1. Here, figure out where the vertex is. Minus b divided by 2a is minus 4. So it's plus 4 divided by 2 times negative 1. You'll get negative 2 for x. Right, it's negative b divided by 2a. Sometimes I make calculation mistakes just because I go too fast. So if I make a mistake, try to figure it out. I don't want to say leave a comment. Try to figure it out and hopefully fix it yourself. If my mistake is too stupid, maybe tell me, write the comment or send me an email so this way I can fix it so nobody else makes that mistake. So here you'll get negative 2 as the vertex x value. How do you find the y value? Replace -2 into the function, into the equation. -2 squared minus -4 times -2 and plus 1. If you add that, you get 4 minus 4 minus, here you'll get -4 minus 4 times -2, too many negative signs. Why is it? Okay, this is plus, sorry. There you go. Plus mistake, plus 8 plus 1. And that turns out to be 5. So the vertex is at -2 and 5. -2, 5. What do you expect from the parabola? Since a is negative, we expect a downward parabola. So I pick a couple more points. You can pick x as 0. What happens at 0? If you replace 0, you'll get y value of 1. And if you pick -4, for example, you'll get y value of 1 again. So here is 0 and 1. That's the point. And you get -4 and 1. That's how the graph looks like. Later on, we focus on these specific points, these black points, because these are specifically the x and y intercepts. If you figure out those points, the graph would be more precise, accurately drawn. Here is what we're going to talk about. We're going to talk about how to figure out those points. We already have mentioned it, but we didn't specifically discuss it for parabola. So we're going to discuss finding x and y intercept for an equation. As I have mentioned before, if you have a graph, the x-intercept and the y-intercept are basically, this is the y-intercept, and you know that the x-coordinate is 0, since it's on the y-axis. The x-coordinate has the property that you do not know the x value, but you know that the y value is 0. Okay, so if you're looking for the x-intercept, what do? Is you let y equal to 0. If you're looking for the y-intercept, you let x equal to 0. So here's an example. Finding the x-intercept and y-intercept. Y-intercept is always the easiest one. You know, x is 0. Replace 0 into the equation. 3 times 0 minus 12 times 0 plus 10. So you'll get 10. Y-intercept turns out to be 0 and 10. How about the x-intercept? You replace y with 0. So what you have is 0 equals 3x squared minus 12x plus 10. This is a quadratic equation. How can you solve it? Factor out if you can. If you don't know how to factor it, just use the quadratic formula. In this case, I'm going to use the quadratic formula. Makes it easier. By the way, you don't need to write 0 equals to that. You can change the equality and write it on the other side. I've mentioned this before. There's no difference. 0 equal to something or something equal to 0. It's the same thing. Okay. A, B, and C are given 3, -12, and 10. So x equals -12 becomes +12 plus or minus square root of b squared is 144 minus 4 times 10 times 3 is 120. Divide by 2 times 3, which is 6. Okay. In this case, it wasn't possible to factor it out. So the x-intercept is not a nice number that you can guess. Okay, 12 plus or minus square root of 144 minus 20, that's 24. Divide by 6. You can simplify it a bit, actually. 24 is 4 times 6, so 2 root 6. And divide by 6 here. You can simplify it a bit more. You can divide everything by 2. You'll get 6 plus or minus square root of 6 divided by 3. You can split it if you want and say this is 6 divided by 3 is 2, plus or minus square root of 6 over 3. That's how you can write this. So what is the x-intercept? 2 plus square root of 6 divided by 3, and y value is 0, and 2 minus square root of 6 divided by 3 and 0. Here's one thing you should be able to find at this point. What is the vertex? If you remember the idea of, if you know the x-intercepts, you know that the graph crosses these two specific points. How do you find the vertex? Is basically the average of those 2 points. What are those 2 points? Those are the x-intercepts. So the average of these two x values is going to give you exactly the location of the x coordinate. If you add these two numbers together, what you get is the square roots will cancel out because they're opposite. 2 plus 2, 4. The average of it is simply 2, which is the same as negative b divided by 2. We already have done this example. We did it last up here. Here. This is the same number. What did we get for the vertex? We got 2 and negative 2. You see that the x coordinate is exactly 2. So we got the same thing. X coordinate is 2. Y value, you can replace 2 into the function and you will get negative 2. I just wanted to show you that these x and y x-intercepts are going to help you to find the vertex if you forget it. Okay, let's try this example as well. Okay, so we're looking for the y-intercept, always easy. You let x equal to 0, replace 0 into the equation. You'll get 0 for x, y becomes 1, this constant. Okay, x-intercept. Again, you do not know the x coordinate, you know the y coordinate is 0. So I set the equation equal to 0. 5x squared plus x plus 1, y is 0, so 0 equals to 0. Use the quadratic formula. X equals negative b is 1, so negative 1 plus or minus square root of 1 minus 4 times 5 is 20, divided by 2a. 10. What do you get? Negative 1 plus or minus square root of negative 19, divided by 10. This is a solution to that equation. And if you look at this, this is an imaginary number. If you have a solution as imaginary, you cannot show it on the real line. So there is no number here that I can say as a real value. This equation does not have a real value solution. So what is the x-intercept? No x-intercept. What does that tell you? That tells you if you graph this function, you have 0 and 1, 0 and 1. This is the y-intercept. The graph goes through this point somehow. Maybe something like this, and since a is positive, it should be upward. But it never crosses the x-axis. Maybe it looks like that. I'm not sure if this is the vertex point, but I'm guessing that either it looks like that, looks like this. The only thing that I know, it never crosses this x-axis. If it does, then you have an x-intercept, real value x-intercept. Okay. And you can guess that the graph is not downward. If it was downward, then you would have had this intercept as well. Okay. So not always possible to have x-intercept, but y-intercept, there is always y-intercept. You always cross this y-axis. Here's one more example. Y equals 2 times x minus 1 squared minus 6. And they ask you to figure out what is the y-intercept and x-intercept. Again, y-intercept always replace 0. If you replace 0, what do you get is 0 minus 1, negative 1, squared times 2. That would be 2 minus 6, you'll get negative 4. Even though it's not in the form of a quadratic, standard form of a quadratic equation, but you can still find the y-intercept by replacing 0. How about the x-intercept? Same thing, you set the equation equal to 0. Replace y with 0. 2 times x minus 1 squared minus 6 equal to 0. What do? add the 6 to the other side. 2 times x minus 1 squared equals 6. Divide both sides by 2. X minus 1 squared equals 3. Now take the square root from both sides. X minus 1 equals square root of 3 if I take a square root from both sides. But remember, when you take a square root, you should consider plus or minus. So either x minus 1 equals root 3 or x minus 1 equals negative root 3. So either x minus 1 equals root 3 or x minus 1 equals negative root 3. What is x? This is 1 plus root 3. Add 1 to both sides. 1 minus root 3. So what are the x-intercepts? 1 plus root 3 and 0. 1 minus root 3 and 0. If you're not comfortable with this solving structure, you can always try to rewrite this in terms of calculate x minus 1 squared, distribute the 2 into it later, then subtract the 6. You can write this the standard form of 2x squared minus, I can calculate that. This would be minus 2 minus 4x. 1 times 2 minus 4. This is exactly equal to that equation. So you can write it either way and figure out the x-intercept. But it's not necessary to go through that. You can always solve the equation this way as well. Okay, this is enough for the vertex, the x-intercept. How about the maximum and minimum of parabola? This is important that this is nothing new. This is something that you already know. What is the vertex point on a parabola? Either it's going to be the smallest y value or it's going to be the largest y value. So the maximum and minimum of a parabola depends on the shape of the parabola. If you have an upward, that means if you have a as a positive coefficient, then you would have a minimum. There wouldn't be any maximum value. But if the parabola is upside down, then you would have a maximum point. And what are the minimum and maximum? Is always that critical point of the vertex. So what we're looking for, if they ask you what is the minimum or maximum of parabola, specifically they want you to find the vertex point. If they ask you what is the value, then they only want the y value of the vertex. But if you find the vertex, you can always answer the value. So here, in this example, given y equals 2x squared minus 4x plus 5, you want to find out what is the max and mean. Max and mean. Before you get into the equation, pause the video and guess, do we have a maximum or a minimum? Okay, since a is positive, what do you know? You know the parabola is upward. So what do we have as a minimum? So here I can say there is no maximum. But how do I find the minimum? The minimum is basically the vertex. So figure out the vertex point. Vertex happen to be at negative b divided by 2a, negative 4 divided by negative 2, be positive 1. This is negative b divided by 2a. And if I replace 1 into the equation, what do I get? Y equals 2 times 1 squared minus 4 times 1 plus 5. You'll get 2 minus 4 is negative 2 plus 5, you'll get 3. So minimum happens at 1 and 3. Sometimes they ask you for minimum, you give it as a coordinate. Sometimes they ask you for the minimum value. That means only tell me the y value. You'll say 3. Okay, if they ask you for the x value of the minimum, then you would say only 1. Generally, when they use the term value, that means they're only looking for the y value. Here's another example. Nothing different. They ask you for the minimum and maximum. In this case, a is negative. So no minimum. This would be the shape. What you have is a maximum point. If I have a maximum, happens at the vertex point. What is the vertex point? The vertex point is negative b divided by 2a. So you'll get negative 1/2. And you need to figure out what is the y coordinate. Replace negative 1/2 in there. Y equals negative 1/2 squared minus negative 1/2. plus 1. I just wanted to show you that not always you expect integer as the outcome. Sometimes square root is possible. Then in that case, the work would be much more than this. Negative 1/2 squared is 1/4. You'll have plus 1/2 plus 1. I hope you know how to add these numbers. 1 and 1/2, 3/2 minus 1/4. You can write it as 7/4. 6/4 minus 1/4 is 5/4. So x is negative 1/2, y is 1/2. Sorry. Y is I said 5/4. Yeah. Right. 1/2 minus 1/4 is a quarter. 1 and 1/4 is the same as 5/4. If they want the max value, say 5/4. I hope it's clear enough. It's just about graphing and figuring out the vertex point. The vertex point is very critical to graph parabolas. If you know the x-intercept and y-intercept, makes the graph much easier to plot. But there is nothing new. Most of these topics we've already discussed it. So I'm going to stop here.